In this video, we are going to talk about the quadratic formula, which comes from the standard form quadratic equation of ax squared plus bx plus c. And the quadratic formula is this big formula right here, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a equals x. And what this gives us is the x-coordinates of when your parabola touches the x-axis twice, once, or not at all. So we're going to talk about how we would use this, but this is going to be the main focus of this video, and it'll be probably in your best interest to work on memorizing it. So let's get started. Here we have the quadratic equation x squared plus 3x minus 7, and we want to find the zeros of this function. We want to figure out what values of x make this equation equal to 0. And what we're going to do is use the quadratic formula to do it. Sometimes you can factor, you can complete the square, but sometimes that's not going to work. And the quadratic formula over here is going to be your one-size-fits-all way of getting your solutions. It'll work for everything. But first, we got to figure out what is our a, b, and c, because we need b, a, and c. So remember that our standard form is ax squared plus bx plus c. So our a here is 1, our b is 3, and our c is negative 7. Now we take these three values and put them into our quadratic formula. Opposite of b, so that's a negative 3 plus or minus the square root of b squared minus 4 times a times c all over 2a. So we have put everything into the quadratic formula. Now we need to work it out. I always like to start with the part under the radical first, which is the discriminant, and we'll talk more about that in a moment. But I like to start with the discriminant here. So this is 9 minus 4 times 1 times negative 7. That is a positive 28. So 9 plus 28 equals 37. Our answer becomes negative 3 plus or minus the square root of 37 all over 2. These are the x values of when our equation is equal to 0. It's not a very nice number, which is why we can't use completing the square or the diamond method to get our zeros. We had to use the quadratic equation. Negative 3 plus or minus the square root of 37, all divided by 2. Okay, let's try another one. Here is our next equation of x squared minus 8x plus 10. Just like before, we want to figure out our a, b, and c. A is 1, b is a negative 8, c is 10. So we'll start off with the opposite of b, which is a positive 8, plus or minus the square root of b squared, so negative 8 squared, minus 4 times 1 times 10, all over 2 times 1. Alright, just like last time, I'm going to work with that discriminant first. Negative 8 squared is 64, positive 64, minus 40, which is 24. We end up with 8 plus or minus the square root of 24 all over 2. And if we wanted to, we could simplify the radical down just a little bit to get 8 plus or minus 2 root 6 all over 2. And then because the 8, the 2, and the 2 are all divisible by the 2, we can finally simple it down the rest of the way to have 4 plus or minus the square root of 6. That would be our solution. But you've heard me talk about this discriminant. We've used it twice now as we've used the quadratic formula, and it's time to learn the important role the discriminant plays in our solutions. So here we have the quadratic formula again, and the stuff that is underneath the radical is called the discriminant. The reason why it's called the discriminant is it helps you decide or discriminate as to what the answers are, how many solutions you're going to have, how many real or complex solutions. If the discriminant is greater than 0, and I'm going to say that D for discriminant, if the discriminant is greater than 0, you have 2 real solutions. If the discriminant is equal to 0, that means you have 1 real solution. And lastly, if you have the discriminant being less than 0, that means you have 2 non-real or imaginary solutions. And think about why that would be true. Why would the discriminant being less than 0 or the discriminant being negative mean we're going to have non-real solutions? And hopefully you can say, oh, it's because you take the square root of the discriminant. And anytime you take the square root of a negative number, you are going to get non-real solutions. So that's why that happens. So let's take a look at some examples here and see what we can do and how many solutions we're going to get. So here we have x squared minus 6x equals negative 11. If you are going to use the quadratic formula, your equation has to be equal to 0. That is non-negotiable. It has to be equal to 0. So I'm going to add 11 to both sides. I have x squared minus 6x plus 11 equals 0. And now I can use the quadratic formula. I'm also going to figure out how many solutions there are based on the discriminant. So our A is 1, our B is negative 6, and our C is 11. Opposite of B is positive 6, plus or minus the square root of negative 6 squared, minus 4 times 1 times 11, all over 2 times 1. All right, let's take a look at this discriminant. Remember, if it's a positive number, we get 2 real solutions. If it's equal to 0, we get 1 real solution. And if it's negative, we get 2 non-real solutions. So let's see what we have here. We have 36 minus 44, which is a negative 8. So we are going to have 2 non-real solutions because the discriminant is negative. And if we work this out to get our answers, we're going to have 6 plus or minus the square root of negative 8 all over 2. We're going to have to take that negative 8, square root of negative 8, and simplify that down, make it in terms of I. So this would be I times the square root of 8. And 8 is the square root of 4 times the square root of 2. So this would be 2I root 2. I can put it together to get 6 plus or minus 2I root 2 all over 2. And then just like we did in one of the previous examples, the 6, the 2, and the 2 are all divisible by 2. So we can turn that into 3 plus or minus I root 2. And that is our solution here. And that's pretty much all there is to the quadratic formula. Getting it memorized is a huge help and a time saver instead of having to look it up every time. And we are able to figure out where our graph crosses the x-axis, if it does at all. Hope you found this video useful, and I'll see you next time.